When we're doing labs and dealing with laboratory data, we need to make sure that we're accurate and precise. So accuracy deals with how close you are to the true value, while precision is how close your measurements are to each other. One way that we account for our uncertainty is significant figures. So your rules for counting sig figs, if it's not a 0 digit, then it's going to count. So 456, none of those numbers are zeros, therefore you should have 3 significant figures. In the next number, leading zeros do not count. So until I get to a non-zero digit, none of those zeros can count. So in this problem, I have 2 significant figures. The third rule says captive zeros always count. So because the ones are on the outside and the zeros are in between the two ones, those zeros have to count because they're captive. Therefore, this has 4 significant figures. Number 4, trailing zeros sometimes count. What that means, you may want to make note, is trailing zeros only count if there's a decimal. So in this problem, there's a decimal place. So the 1 counts and both of those zeros. It doesn't matter if there was 2 zeros or 5 zeros, all of the zeros would have counted. For the first one though, there's no decimal at the end. So the 1 counts, this 0 counts because it's captive, the 2 counts, but this 0 does not count for significance. It's very important because it changes the number from 102 to 1020, but it doesn't count for sig figs, so it's 3 sig figs. And finally, exact numbers are going to have an infinite number. If you're counting something that's not a measurement, such as 5 students came in the room, or 20 apples, or 30 pencils, those are exact numbers, as are conversion factors, so those have an infinite number of sig figs. So go ahead and pause the video and figure out how many sig figs these 5 problems have. Restart when you have your answers. So the first one you should have said was 3. The 2 at the end do not count because there was not a decimal. So we have 3 sig figs. The second one, leading zeros didn't count, but there's a decimal, so the 0 at the end should have counted. Therefore, we have 3 sig figs. The next one was an infinite number because that was counted. The fourth one, when something's in scientific notation, all the numbers should count because there'll be a decimal. Therefore, trailing zeros have to count. And you can't have a 0 before the decimal in scientific notation if it's proper. Therefore, this has 3 significant figures. The last one, we have a 0, which is captive, and a 0 after the decimal, so it has 4 significant figures. Besides just counting sig figs, when you are doing measurements, you're going to have to put your answer in the correct number of significant figures. When you multiply or divide, your answer should have the proper number of sig figs as the least precise measurement. So 1.34 has 3 significant figures, and then 0.04 has 1 sig fig. So one number has 3 sig figs and the other number has 1 sig fig. So you plug that into the calculator and you get 0.0536. But your answer can only be in 1 significant figure, so it's 0.05. You're only going to round to the proper number of sig figs at the end of the problem or at the end of a section if you're switching between rules. If you're adding or subtracting, you look at decimal places. So for instance, 1.34 plus 2.3. This number has 2 numbers after the decimal place. This one has 1 number after the decimal place. Notice I'm not looking at sig figs. This one would have had 3 sig figs and 2 sig figs. I'm looking at numbers after the decimal. So when you add those up, you get 3.64. But I need my answer in one decimal place, so that's just going to turn into 3.6. This problem has division, multiplication, and addition. So when you have parentheses, you're going to do that part first. My addition, I'm looking at decimal places. So when you add that up, you get 18.925. But I have 3 decimal places and 2 numbers after the decimal. Therefore, I need it in 2 numbers after the decimal. So this is going to round to 18.93. Notice that 5 rounds that 2 up. So always pay attention when rounding. Does my number stay the same or round up? Now I can plug 9.99 divided by 22.41 times 18.93. I have 3 sig figs, 4 sig figs, and 4 sig figs. So my final answer should have 3 sig figs, or A. Go ahead and pause the video and try this one on your own. Make sure that you're putting your answer in the correct number of sig figs, and then restart. So the most common way that you're going to see the addition and subtraction rule is through lab data. In this problem, you had a beaker, and then you had a beaker and iron. And we're trying to find out the mass of just the iron. Therefore, we have to get rid of the beaker mass. So we subtract these two values. They both had 2 decimal places. So when I subtract, I need to have my answer in 2 decimal places. So it comes out to 14.45 grams. If it had come out to 14.5 or 14.4, I would have had to add a 0 at the end because I had to have 2 numbers after the decimal. One last thing about sig figs is you have to be able to read sig figs with your equipment. So you always read what you can see accurately plus 1 more digit. So what we mean by that is here's a 25 milliliter graduated cylinder. If you look at the gradations, it's increasing by 1 milliliter each. So if I had said that the volume is right at 11, that tells me that I guessed on the 1. But I didn't guess on the 1. I know it's 11. So I have to add 1 more digit to that and say, well, I think it's 11.0. I know for sure it's 11. I'm guessing that it's 0.0. Or maybe I think it's 11.1. Both of these are acceptable answers because the last digit is the digit of uncertainty. We know for sure it's 11. We don't know the 10th place. The same lines, I can't say 11.10 because that means I know for sure it's 11.1. But based on this graduated cylinder, I don't know it's 0.1. I'm guessing that it's 0.1 or 0.0. And then make sure that you're putting units on your answer. So go ahead and read this next graduated cylinder on your own. Restart when you have an answer. So this graduated cylinder, you can read to the 10th place. So we know that it's 4, or between 4 and 5, and we know that it's 4.8 because it's on the 8, which means I'm going to guess that it's exactly 4.80 milliliters. If you had 4.81 or 4.82, then those are acceptable answers because, again, that last digit is a guess digit. But it really shouldn't be more than 4.84 because it's not between the 8 and the 9. Okay, go ahead and try the one on the left and restart after doing just the one on the left. So looking at your answer, if your answer is not between 5 and 6, then you have an issue. Because if you look at this piece of equipment, that meniscus is between the 5 and between the 6. So it can't be 6 point something because that doesn't make sense to be between a 5 and a 6 whole number. This piece of instrument is a burette. With a burette, or it could be a eudiometer, it starts at 0 on the top and goes down to, starts with 0 on the top and goes down to 50. So if you got that far, then you've got to say, well, I know it's between a 5 and a 6. I know that it's 5.6 something. So 5.65 is the answer I gave. Maybe you said 5.64 or 5.66, but you had to have an answer to the hundredths place. If you didn't, it would not be correct. And let's do that last one on the right and restart when you have your answer. So this one, just like the one on the left, was also a burette. And just like the one on the left, it should be to the hundredths place. So we have 23.1234, and then I'm guessing that it's between. So maybe 23.44, 43, 45, somewhere in there, maybe even 46. Okay, that concludes those. You can go to the practice problems and solve that section of your notes, or the problems.